Okay, continuing with in this case, the last section of the notes for 7.2 in Algebra 2. Starting with problem 19. Okay, we learned at the start of this that we can combine two square roots when they form a product, and you can see that we have a multiplication there. So we're going to combine these under one square root, and 7 times 21 is 147. And now the goal is to split it up again, but this time to split it up in such a way that we get a perfect square in the front. So if you take the y equals key on your calculator and do 147 divided by x, and go to your table of values, you'll see that, about 3 lines down on the right, you'll see 49. And 49 times 3 is 147. But now we have a perfect square in the front, so it simplifies. And you get 7 root 3. Okay, we're going to take the same approach on this one. You combine the cube roots here, 25 times 10. And then you display the factors of 250 by typing this on your y equals line of your calculator. Go to the table of values and cruise down on the right-hand side. You'll see 125 on the second line. That's a perfect cube. 125 times 2 is what you'll see. And the front simplifies to 5. So 5 times the cube root of 2 is how that one simplifies. Okay, on this next one here, the product of the outside numbers is 3 times 4 would be 12. And then when you take the 6 times 18, you get 108. And the x to the 6th times x to the 5th will give x to the 11th. You add your exponents when they're side by side like that. Okay, now we have to figure out how to split up that cube root. So we'll prepare the ground here, 2 cube roots. And if you take 108 divided by x on your calculator and cruise down the right-hand side, you'll see this 27 times 3. Actually, 27 times 4 is 108. Now, 11 doesn't divide by 3, but if you bump it down 2 spots to 9, that'll work. So the extra 2 you just have to put in the back and be satisfied, not doing anything with it. That middle section there simplifies to 3x to the third. We divided this 9 by the 3 that's on the outside. That's how you handle the exponents. And then we're going to keep this 4x squared, cube root of 4x squared as part of our answer. And the only thing else we can do here is combine the 12 times 3 to get 36. X to the third times the cube root of that 4x squared. And that one's done as far as we can take it. Okay, the last one here, we have the situation where there's just a whole number on top and not a square root. We fix that by multiplying it by square root of 1, which, by the way, is just multiplying by 1. But now you can see that the 10 stays out there, and you can go 1 over 3x here. Now, if you take that 3x, you can shoot for getting it into a 9x. You can get a 9 out of it, by multiplying by 3. And then if you want that x to work, you've got to make it up to x squared, and that'll do it for you. So that action will take the bottom and make it a perfect square. The bottom is 9x squared, square root of 9x squared. So now you have 10 square root of 3x on top, and the bottom simplifies to 3x. And that's as much simplifying as you can do on this problem. Okay, we have problem 23. And right away on the outside, I see that I can simplify these numbers here by dividing by 4. I'm going to do that right away. So I'll get negative 1/3. And I'm going to go ahead and put these square roots together. Now I got to make the bottom into a perfect square. So I'm going to multiply it by itself here. And that should do it. Let's see, we got a negative 1 square root of 6xy on top. And on the bottom, we have a 3 square root of 4y squared. And this is now a perfect square, which is why we did all that work. And that ends up being -1 times the square root of 6xy. And the bottom is 3 times 2y. So we end up with negative square root of 6xy. I'll leave the 1 off this time. And on the bottom, 6y. And that takes us, oh shoot, yeah, that's right, 6y on the bottom. And that takes us all the way to problem 23, which happens to be the last problem in these notes. Now, I'm going to give you a little bit more here, just because with a square root, there's a real handy shortcut. And if you've got any blank area on the notes, I want you to do this here. So let's say you have square root of 5 over square root of 2. Now, you want to make this bottom into a perfect square, and one easy way to do it is to multiply it by itself like this. And you only do this, by the way, with square roots. Now, what's going to happen here is you're going to get square root of 5 times square root of 2 over the square root of 4, which, if you simplify, looks like this. I'm going to keep that square root of 5 square root of 2 like that. Eventually that's going to be square root of 10, but you get a 2 down here. And then eventually you're going to get square root of 10 over 2 there. Now here's the deal. If I go back to the original, and give me a second to set this up here. I'm going to make an exact copy of that, and I'm going to place it right on top. And I'll show you how to accomplish getting from the first part all the way down to that step in an easy fashion. Okay, so what you're going to do here is you're going to copy the top, and then you're going to take a copy of the bottom and bring it up to the top and leave most of the copy that you get on the bottom. Let me do that. You get a square root of 2. That's copying the bottom, but what happens here is you actually ditch the square root sign when you do it. So the bottom goes up to the top. In other words, this denominator just travels up top, and it leaves what I deem the shadow behind. So let me give you another example of that. Let's say you had just a whole number, 3 over root 6. The next line would be 3 with the root 6 next to it, but you leave just a plain old 6 behind, and you'll get that done very quickly. This would go on to be root 6 over 2 when you cancel like this. So you can get to the end really quickly if you do this. So let me give you one more example of that. Let's say you had square root of 15 over square root of 5. Well, you're going to write it like this. Square root of 15, that's the top. You copy the bottom, and then you put the shadow of the bottom behind. And now it'd be square root of 75 over 5. And that top breaks up. So you get 5 root 3 over 5, and now the 5's cancel and you end up with root 3. But this first step where you take this upstairs and leave the shadow behind, I like to call it kicking the radical upstairs and leave its shadow behind, will save you a lot of steps in between. And that's the end of this note set.